The differential form of the fundamental laws, tutorial number 6. The x component of the velocity vector is measured at point A, B, and C 5 millimeters apart as 11.3 meter per second, 12.6 meter per second, and 13.5 meter per second respectively in the incompressible steady plane flow shown below. Estimate the y component of velocity 4 millimeters above point B and the acceleration at point B. So we have the chamber like this. So we have the coordinate of A, B, and C here is 5 millimeter apart, and the velocity for A, B, and C is given in the question. So we take it as the incompressible steady plane flow like this. So this is the continuity equation from our previous lesson. So I hope you could remember this very well, and then we could simplify everything. The velocity, the density is constant, so we could neglect the value of all of the density here because there are no changing according to time and x, y, or z direction here, and the value of rho here it also can be neglect because we can transfer it to the right hand side here, so it's become invisible in this term, and we have only two-dimensional, so the value of w here is not exist. So we finally could say that the continuity equation can be written as del u over del x plus del v over del y. So we bring the terms of u to the other side here, so we have dv dy equal to negative del u over del x, and then to calculate del v over del y, we could use the velocity given in the question. So usually in this condition, we will calculate, we have 3 points here, we will use the point A and C. So we have A is 11.3 and C is 13.5 because it is just to make our calculation accurate to have the value between these two values. So we have 13.5 minus 1.13, and the dx here, del x here, is actually the gap between point A and point C because it is 5 millimeter apart here. So the total from A to C is 10 millimeters, so it's equal to 1 centimeter. So we write down as 0.01 meter here. So we could get del v over del y is equal to minus 220 meter per second. So to calculate the dv alone, so we have to bring the y to the right hand side here, and because the question want to calculate what is the velocity of at 4 millimeters above the center point, so we substitute the value of y here as 0.004 to reflect the 4 millimeters area, so we get it is equal to minus 0.88 meter per second. Then we need to calculate the acceleration. So this is the acceleration equation. I'm not given it in the notes lesson, so I give here in this tutorial. So we could calculate the acceleration for x direction as ax equal to del u over del t plus u del u over del y plus v del u over del y plus w del u over del z. So because it is a steady flow, so we assume that du dt is equal to 0, and we only have the x component, so we have v and w is equal to 0, so we could cancel these two values. So finally we could calculate the acceleration for x direction is u del u del x. So we have u is 12.6 meter per second, so we have it from the question. So and then du dx is calculated previously, it's 220, so we have it is 2772 meter per second square.